The Subcommittee on Space and Aeronautics will come to order. Good morning. Welcome to today's hearing entitled A Review of the Federal Aviation Administration's Research and Development Programs. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures for today's witness panel. Before we get started, this being the first meeting of the Space and Aeronautics Subcommittee for the 112th Congress, I'd like to ask the Subcommittee's indulgence to introduce myself, welcome back returning members, which seems to be a little empty. There's a lot of competing interest this morning for members' time, but they'll be coming and going, and to introduce new members on our side of the aisle. Afterwards, I'll recognize Mrs. Fudge to do the same. It is an honor and a privilege to me to chair the Space and Subcommittee for this Congress, and it's a position I do not take lightly. I want all members of the subcommittee to know that my door is always open, that I will endeavor to serve all members fairly and impartially, and that I will work to serve the best interests of Congress and all Americans to ensure that the agencies and programs under our jurisdiction are worthy of the public's support. In the last Congress, this chair was held by Representative Gabrielle Giffords, an extraordinary lady and leader who was a fierce advocate for our nation's space program. I ask all in this room to keep Representative Giffords in their thoughts and prayers as she continues to recover from her wounds. And so there ain't nobody really to welcome back on this side. We'll skip this part, and then I'd like to go ahead and, Mrs. Fudge, if you'd like to introduce your members. Okay. Okay. At this time, I recognize myself for 5 minutes for an opening statement. Good morning. I'd like to welcome everyone to today's hearing. We have a distinguished panel of witnesses before us who will discuss the Federal Aviation Administration's Research and Development Program. And at the outset, I wish to extend a sincere thank you to each of our witnesses for taking the time and effort to appear before us today. Please know that your testimony and wisdom will be of immense help to the members of this committee. Our national air transportation system plays a critical role in every American's daily life, enabling aviation services to conveniently reach into virtually every corner of our nation. For cities and towns, large and small, aviation has become essential to sustaining commerce, public safety, and leisure. It is a capability that has enabled our society to flourish in many ways, and while economists have often spoken about the incalculable benefits that were enabled by the development of the interstate highway system, there's no doubt that aviation has had a comparable effect, stitching together virtually all regions and communities of our nation. With a robust commercial air transportation system, many forms of commerce and intercity travel would be significantly diminished. With that in mind, the Federal Aviation Administration's role of safely managing and regulating our national airspace system and its users is an enormous enterprise. Demand on the NAS has in recent past strained FAA's ability to efficiently manage the system, in part due to the limitation of the current radar-based system. We cannot afford to continue in this way. It simply can't absorb additional traffic that will surely come once our economy rebounds. Just yesterday, the FAA released its annual forecast, predicting that air travel will double over the next 2 decades. FAA also predicts that the system will move 1 billion passengers annually by the year 2021, just 10 years from now. In the safety arena, FAA is confronting a wide spectrum of challenges, such as developing the knowledge to ensure safe operations of aging aircraft, understanding the performance and failure modes of new materials used in aircraft structures, new automation systems, understanding man-machine interfaces and human factors, and researching and certifying new fuels for piston and turbine power plants, just to name a few examples. It is critical that FAA meet these challenges, and to do so, it must have a robust and well-managed research and development program that enables the agency to accommodate growth and accommodate new technologies. This morning's hearing will give us an opportunity to hear from industry experts and senior agency officials to help us understand the successes and obstacles FAA must confront as it continues to advance our nation's air transportation system. It is critically important that FAA and its industry partners provide good rationale for agency-supported research projects and activities and to justify the level of funding. These are uncertain times. Congress is facing enormous pressure to reduce the size of our budget deficit, and every federal activity will come under intense scrutiny, no matter how meritorious you and I might think they may be. Thanks again to our witnesses. With that, I now recognize the gentlelady from Ohio, Mrs. Fudge, for her opening statement.
Thank you very much, Mr. Chairman. And I want to thank the staff. As you know, I am sitting in for someone who is standing in. Mr. Costello is actually the acting ranking member, and I am standing in for him today because he is in another hearing. And we're both just doing all we can to hold down the fort until our friend Gabby Giffords returns to assume this position as ranking member of the subcommittee. So I thank you. Mr. Chairman, thank you for holding this hearing today to review the Federal Aviation Administration's research and development programs. Mr. Costello has asked me to sit in the ranking member's chair as the Transportation and Infrastructure Committee is marking up the FAA bill as we speak. I ask that his prepared remarks be inserted for the record. Certainly, that's okay.
Without objection.
Thank you. I would like to welcome the new members who are not here, but I will tell you who they are. The gentlewoman from Alabama, Ms. Sewell, and the gentlewoman from Florida, Ms. Wilson. We look forward to their participation on this subcommittee. Aviation is a vital part of the U.S. economy, making up as much as 9% of America's GDP and representing the fastest growing source for technological exports. R&D is an important component, and FAA's contribution is vital. In particular, FAA's implementation of NextGen, I don't know what I'm doing today. In particular, FAA's implementation of NextGen is essential to moving from a radar system to a satellite-based system. The Science, Space, and Technology Committee has jurisdiction over the research and development for NextGen, and I am hopeful we can provide adequate funding for this vital program. Some members of Congress have suggested we reduce or eliminate funding for NextGen and other FAA R&D programs. I am convinced cutting these programs now would present major concerns for aviation safety in the coming years and push our aviation industry backwards instead of moving us forward. Further cutting funding now would actually eliminate future opportunities for FAA to save billions of dollars through the agency's facility consolidation efforts, reductions in fuel consumption, and decreases in engine emissions. I recognize the need to reduce federal spending and address our deficit. However, I believe we cannot jeopardize the safety and security of the flying public or the future of the American economy in the process. I will work with you, Chairman Palazzo, to ensure our title of the FAA bill reflects our interest. I thank our witnesses for being here to testify today, and I look forward to working with all interested parties to develop a strong, fiscally responsible, and forward-looking FAA bill. I yield back, Mr. Chairman.
Thank you, Mrs. Fudge. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. I would like to mention that our chairman, Mr. Hall, is here, and if he would thank you for coming. And do you have anything you'd like to say? Thank you. And Mr. Rawbacher's here. He's a returning member. Chairman, at this time, I would like to introduce our panel of witnesses, and they will proceed to hear from each of them in order. Our first witness is Ms. Victoria Cox. She is Senior Vice President, NextGen, and Operations Planning, Air Traffic Organization with the Federal Aviation Administration. Next, we will hear from the Honorable Calvin Scoville, Inspector General of the U.S. Department of Transportation. Following Mr. Scoville, we will hear from Dr. John Hansman, Chairman of the Research, Engineering, and Development Committee of the Federal Aviation Administration and a Professor of Aeronautics and Astronautics at the Massachusetts Institute of Technology. Our final witness will be Mr. Peter Bunce, President and CEO of the General Aviation Manufacturers Association. Thanks again to our panel for being here this morning.
Mr. Chairman, I'd like to ask for a motion for personal privilege here. I'd like to have the opportunity to ask one question before the testimony begins that could be followed up on after the testimony.
Hearing no objections?
All right.
You're granted.
I would like the witnesses to be thinking about this question so that by the time we get to it, maybe we could they could give it some thought and give us a serious answer. And that is, I would like you to tell me what you believe the number one priority that you believe the FAA and that we should have in this arena. What's the number one priority? And also, most important, tell us what the lowest priority should be. So when we have to balance budgets, we will have some direction from you. And I needed to ask that before to give them time to think about it. So thank you very much for granting me that 1 minute.
As our witnesses should know, spoken testimony is limited to 5 minutes each. After all witnesses have spoken, members of the committee will have 5 minutes each to ask questions. I now recognize our first witness, Ms. Victoria Cox, Senior Vice President, Federal Aviation Administration.
Thank you. Good morning, Committee Chairman Hall, Subcommittee Chairman Palazzo, Congresswoman Fudge, and members of the Subcommittee.
Please pull the microphone closer. Thank you.
I'm Victoria Cox, Senior Vice President for NextGen and Operations Planning Services in the Air Traffic Organization of the Federal Aviation Administration. It's a pleasure to meet the new members of the subcommittee today, and I look forward to working with all of you. It saddens me that Congresswoman Giffords is not here, having appeared before her last year, and we at the FAA join the rest of the nation in keeping her recovery in our thoughts. Research and development has been essential and necessary to aviation since its very beginning. Where would we be without the Wright brothers' studies and experiments on the dynamics of flight? The FAA's Research, Engineering, and Development, RE&D program carries this legacy forward as aviation continues to thrive and change. Aviation is a vital national resource for the United States. The aviation industry alone directly employs 1.1 million people and supports more than 11 million jobs in related industries and through spending by direct aviation employees. Altogether, this direct support represents 6% of the gross domestic product of the United States. In addition to the support it provides for commerce, jobs, and economic development, we cannot forget aviation's integral role in law enforcement, emergency response, and in the national defense and security of the homeland. These benefits of the aviation industry require that America's air transportation system remain the best in the world. But being the best has a price. To maintain leadership requires constant introduction of new technologies and procedures, innovative policies, and advanced management practices into the aviation system. In order to do that, we need to make sustained investments in advanced research and technology development. A robust RE&D program allows for cost-effective implementation of vital new technologies and capabilities through concept development, testing, early risk identification, and mitigation. There's often an incomplete understanding of what the Next Generation Air Transportation System, or NextGen, is and what it can do. The concept is simple. NextGen is a set of technologies, processes, procedures, and policies that together will revolutionize how people fly. It's a radical departure from the ground-based radar of years gone by, a shift towards satellite control and navigation. It's a game changer for the controller, the pilot, and the passenger. With the technology and procedures of NextGen, we vastly improved the safety, efficiency, and overall performance of air transportation. But we are well aware that that's not the whole story. If we want to get maximum return on the investment, if we want to support unconstrained market growth in aviation, we must take an aggressive approach to upgrading our infrastructure to maximize the benefits of NextGen. At some point, keeping legacy systems going becomes more costly than replacing them with new technology. To that end, we've developed a research portfolio that will address today's needs while laying the foundation to address the needs of the future of NextGen. The FAA's research and development is geared to practical applicability. While we are developing NextGen with an eye towards long-term transformation of the air traffic control system, we're also evolving the system in the near to mid-term as well. FAA's research portfolio is divided into related fields. Our core and NextGen RE&D funding includes research that supports aviation safety and regulatory processes. Other research and development activities are aimed at introducing innovative new technologies into the air transportation system that will deliver future operational capabilities envisioned for NextGen. My written statement provides examples of our ongoing efforts and their importance to our overall success. I would be remiss if I did not point out that we are not alone in our efforts. We're committing to working more smarter and more leanly, and to that end, we're partnering with others to leverage their knowledge and resources to augment ours. We engage with industry via advisory boards and with a multitude of international organizations. The Joint Planning and Development Office, or JPDO, facilitates partnerships across government agencies, including FAA, NASA, and Departments of Defense, Commerce, and Homeland Security. The JPDO supports a future vision for NextGen by developing the long-term research plan for improvements that extend beyond the midterm planning window of the FAA. Our approach to research and development is focused on maintaining our leadership in aviation while leveraging our partnerships to the maximum extent possible. I believe this approach is bearing fruit. As the aviation industry continues to evolve and change, it's vitally important that our country leads the world in this sector. I look forward to working with this Congress to ensure that we do. This concludes my prepared remarks. Thank you again. I'll be happy to answer questions.
Thank you. I now recognize Mr. Calvin Scovel, Inspector General, U.S. Department of Transportation.
Mr. Chairman, Ranking Member Fudge, members of the subcommittee, thank you for inviting me here today to testify on FAA's NextGen efforts. NextGen aims to fundamentally transform our aviation system to better manage air traffic and reduce congestion over the next several decades. Since FAA launched this complex effort in FY 2004, we have reported on the management challenges FAA faces in delivering NextGen's promised benefits. Today I will discuss two areas that could impact FAA's ability to meet long-term NextGen goals. First, schedule delays and cost increases with the En route Automation Modernization Program, or ERAM. And second, coordination gaps with FAA's partner agencies on key research and development efforts. I will also highlight actions needed to strengthen FAA's management of NextGen initiatives. ERAM is NextGen's primary tool for processing flight data and serves as the hub system for achieving some of its most beneficial capabilities. Without ERAM, other programs intended to provide more efficient data sharing and airspace routes will not be possible. FAA originally planned to fully deploy ERAM by the end of 2010 at a cost of $2.1 billion. But significant software problems at the initial test sites have pushed deployment out by 4 years. FAA estimates that overall, ERAM delays will cost an additional $330 million. Our work and a recent MITRE analysis, however, suggests total cost growth could be significantly more, as much as $500 million. FAA will also incur other costs to sustain aging equipment longer than planned and to retrain controllers on both legacy and ERAM systems. Cost escalations of this magnitude could affect FAA's capital budget and crowd out other projects. In addition to keeping key programs on track, FAA must address research and development gaps with its partner agencies, such as the Department of Defense. Multi-agency coordination on NextGen is not only mandated by law, but is needed to achieve key capabilities and stay on track with NextGen's cost, schedule, and performance goals. These key research gaps concern integrating weather information into advanced automated systems, establishing joint surveillance requirements to securely track aircraft, incorporating unmanned aircraft systems into domestic airspace, and assessing NextGen's human factors impact on pilots and controllers. As we reported last June, FAA's delayed decisions on critical requirements have impacted other agencies' R&D plans and NextGen's overall progress. For example, FAA has yet to determine how much responsibility to delegate to pilots versus controllers and ground systems to track aircraft. Another major factor in NextGen cost planning will be the degree to which FAA consolidates or eliminates air traffic facilities. At the same time, FAA continues to lack an integrated budget document to track partner agencies' involvement in NextGen and align resources. FAA has been working toward this for over 4 years. While FAA's partner agencies support NextGen, some have not adjusted their R&D budgets and programs specifically for NextGen efforts. It's therefore difficult for FAA and Congress to determine if FAA is leveraging the right research, if funding is adequate for specific efforts, or if projects will improve the air transportation system and at what cost. To strengthen the multi-agency approach and better manage long-term NextGen initiatives, there are 5 key areas where FAA needs to take action. First, clarify FAA's Joint Planning and Development Office's responsibilities for critical next-gen development areas, such as simulation and modeling, technology transfer, prototype development, and policy formulation. Second, finalize performance goals and metrics for NextGen. Until FAA moves beyond the broader goals it has laid out, it will be difficult to assess short and long-term efforts for improving airport arrival rates, reducing fuel burn, or decreasing FAA operating costs. Third, complete efforts to establish an integrated NextGen budget document. Fourth, fully leverage DoD's expertise. While DoD contributes to NextGen in an advisory capacity, FAA has not yet fully assessed DoD's vast research and development portfolio or technology that could help reduce risk with the precision landing systems envisioned for NextGen. Finally, secure a workforce with the skill sets needed to execute NextGen. While FAA recently completed an initial acquisition workforce plan, the plan contains no specifics on the method or timing of this effort. We have work underway to examine FAA's plans for determining its acquisition workforce needs and its progress in addressing them. Mr. Chairman, this concludes my prepared statement. I'd be happy to address any questions you or members of the subcommittee may have.
Thank you. I now recognize our next witness, Dr. John Hansman, Chairman of the FAA Research, Engineering, and Development Advisory Committee.
All right. As you can see, I have some slides here. Chairman Palazzo, thanks for the opportunity to talk, and members. Faculty members can't talk without slides. I wanted to motivate first why we're doing the modernization of the system. So if you haven't seen this is a movie produced by NASA looking at the U.S. system. Started in the afternoon period. If you look now, we're going into the overnight period. You can see the transcontinental flights and the flights going into and out of the cargo hubs. As dawn hits the East Coast, you can see the traffic expand and blossom. And as the peak midday period in the system, we're tracking about 4,000 to 5,000 airplanes in the system. So this is a highly dynamic system that's totally interrelated. Now, this is a picture of the system when it works well. Let me show you a picture on a day when weather hits New York. This is just flights going into the New York airport. You can see the weather in the upper right. You can see when the weather starts to hit New York, I want you to look for airplanes going into holding patterns. You can see that as the weather hits, airplanes start to go into holding patterns all the way across the U.S. And you also see them go down the East Coast. So when we have a perturbation in the system, it's so tightly coupled that these perturbations propagate through the system and result in delays throughout the entire system. So if we look at why we're doing modernization, why we do research and development, there's really, right now, I mean, there's a number of drivers, but there are 4 key drivers. The first is safety, and we've actually done a remarkable job in safety. You can see this is data from Boeing looking at the commercial fatal accident rate. You can see it's gone down tremendously. We have an incredibly safe system. We've also been worried about in recent years capacity and delay. As the demand in the system comes up, as we get the types of growth that we've had, delays have gone up, and you can see in the bottom left the delay data. You can see the drop after September 11th. You can see the delays built up again afterwards. You can see that the delays have gone down in the past couple of years, in part due to the demand coming off the system with the economy and the downturn. It's our expectation that when the demand comes back up, the system will again reach its capacity constraints and we'll have significant delay in the system, which is why we need to modernize. Now, there's 2 other really new drivers or emerging drivers that have occurred in recent years. One is the concern on fuel availability and cost. In the upper right, you can see that the rapid run-up in fuel costs, there's a recent drop, but they've run up again, has really driven the need for more efficiency in the operation of the system. You can also see that there's increasing concern about environmental impact, in particular greenhouse gas emissions. Today, aviation represents about between 2 and 3% of the man-made anthropogenic greenhouse gas emissions. As pressure comes to reduce greenhouse gas emissions, other emitters, particularly ground-based emitters, have much easier alternatives to go to low-carbon alternatives. So the percentage of contribution from aviation in the future is going to rise. There will be increasing pressure on aviation to reduce that. So these are drivers for for why we're doing the research. Now, I want to just get to the questions I was asked and try to address them quickly. First is, what are the REDAC's chief concerns about the agency's R&D initiatives with regard to content and funding? Are there gaps? If so, what are they? The REDAC's generally supportive of the content of the R&D programs. There are some gaps. In particular, there's a concern about the complexity of the next-gen research and development plans, which actually make it hard to evaluate if there are gaps. There's a real need for processes to accelerate next-gen implementation. I'll address that more in the next question. And there's a well-known problem of how to introduce unmanned air systems in terms of their operations in our national airspace system. Another concern, which was voiced previously, is the level of technical expertise in key areas, in particular areas of digital systems and software, which is very hard for the FAA to compete for talent in the open market. In terms of how well does the agency's research portfolio support timely implementation of NextGen, I would say the technology is not the issue. The challenge is actually in the operational approval of NextGen capabilities and procedures. It's very difficult to prove that this new thing that we're going to do is safe enough that it won't degrade the safety of the system. That results in significant delay. Finally, how would you assess the role and effectiveness of the JPDO as the FAA's long-range planning office? JPDO has not been effective recently as a long-range planning office for the FAA. It was effective in the initial definition of NextGen, but its effectiveness has waned over the past years. I'm happy to talk more about it in the questions.
Thank you. I now recognize our final witness, Mr. Peter Bunce, President and CEO, General Aviation Manufacturers Association.
Chairman Palazzo, Congresswoman Fudge, Chairman Hall, and other distinguished members of the subcommittee, thanks for the opportunity to come talk to you today. I'm an active jet and piston pilot flying in the system every day, so everything that my government colleagues talked about today about NextGen is very sacred to me. But I want to talk about a part of the research and development budget that is particularly important to a segment of the industry that I represent. GAMA, General Aviation Manufacturers Association, represents 70 of the world's leading producers of manufactured aircraft engines, avionics. And as we move to NextGen, we're moving much of the system from a ground-based system up to avionics that are installed in the air so that we can go and better handle traffic, as my colleagues have mentioned. So I have responsibility for everything from Boeing business jets down to aircraft like small Cessnas and Pipers. And that part of the industry, the piston part of the industry, is in a tough shape right now. Economically, we've lost a lot of jobs, over 20,000 since the economic downturn happened. And about 45% of the product that we were producing back in 2008 is gone. But with all that said, our companies are heavily invested in our R&D and looking for, as the economic conditions start to pick up, an ability to go and produce even more fuel-efficient products. But on the piston end, we're being squeezed between the Environmental Protection Agency on one side and the FAA on the other, and that's in the area of leaded avgas. Now, piston aircraft operate on a fuel that was developed primarily during World War II, and all our engines were developed to be able to use the lead content which is in that fuel. They're designed to very close tolerances, and when you start to take the lead out, what happens is you get what's called detonation. You might recall when we switched to unleaded fuel in a lot of our cars, we got knocking. But a car, one, you can pull over to the side of the road, and two, it's got a very robust engine block. Aircraft engines don't work like that. You have detonation and cylinders blow off and people get hurt. So we've got the EPA on one side saying you've got to get the lead out of the fuel. We've got the FAA regulator on the other side that the only way we can get product to market, the only way we can change the fuel is have to go through the FAA and they have to certify the new fuel. Now, I'm talking low dollar amount. It's about $2 million for each year of this reauthorization bill that we're talking, but there is a tech center up in Atlantic City where we provide some of the engines for them to be able to research the new fuels that we develop. We fix the engines when they break, but we have to have this because the only way we can convert to an unleaded fuel, and we can't just use autogas. 70% of our aircraft out there, there's no way you could use autogas. You'd have the same problems. You'd have engines blowing apart. The only way we can get to a new fuel, which our different companies and our industry is developing, is to have that capability up in Atlantic City. So Mr. Rohrabacher talked about what my number one priority. Small dollars, but it is truly my number one priority because of the squeeze that we that we feel right now in our ability to convert the industry. There's other things for general aviation that become very important, and my colleagues have talked about NextGen. That's extremely important to us, but being able to leverage our universities that are out there. There's an acronym called CGAR that basically is our Centers of Excellence, and it's called the Centers for General Aviation Research, and we have that at Embry-Riddle University, Florida A&M, University of North Dakota, University of Alaska, and a couple other great institutions out there that have great aviation programs. And we leverage these smart people that really understand software. And they're able to go and try to figure out how we're going to take this satellite-based system that we're all going to and integrate it with the avionics to be able to have more and more capability delivered out there so that we can go and address these congestion issues that, again, my colleagues have addressed. Also important to us in the R&D program is the CLEAN initiative, the Continuous Low Energy Emissions and Noise initiative that basically is our ability to make engines and airframes and also the materials that we use on aircraft to make them lighter and be able to leverage all of that technology to be able to go and reduce our fuel burn. Because when we reduce our fuel burn, we go and cut emissions, but we also have capability to cut noise. And noise, as we all know, is an important issue, much more important in Europe, but very important here in the States. So all of these initiatives play into NextGen so we can do things on the aircraft manufacturing side, but we also can do the way we operate aircraft on the operational side to go ahead and reduce emissions out there. So we think that the program that we're able to leverage with the universities is very important to us, the CLEAN initiative, and of course what we're doing in NextGen as well. Thank you, and I look forward to your questions.
I thank the panel for their testimony, reminding members that committee rules limit questioning to 5 minutes. The chair will at this point open the round of questions. The chair recognizes himself for 5 minutes. Dr. Hansman and Mr. Scoville, given the research and development projects and activities being undertaken by FAA, how would you characterize the level of resources being provided by the agency? Are resources commensurate with the R&D projects, goals, and schedules?
Over the past years, I would say the resources have been good and have been commensurate with the general need. With the ramp up to NextGen, in some sense, it was hard to figure out what needed to be done, and there was a little bit of scrambling. But I say to first order, the resources have been appropriate.
Mr. Chairman, I would concur. We think that funding over the past number of years targeted toward NextGen has generally been adequate. We have noted, as I stated in my opening statement, execution or implementation problems on FAA's part carrying out the programs that have been approved and some of which have been mandated by Congress. We see room for improvement in the multi-agency efforts, specifically with regard to weather and the Department of Commerce, DOD and DHS on surveillance, Department of Defense with unmanned aircraft systems, and finally NASA perhaps on human factors. FAA and its agency partners can do a much better job in those areas.
Mrs. Cox, FAA's budget will come under intense scrutiny now and for the foreseeable future. If research and development funding were reduced, where do you believe the cuts would be taken, and how would FAA manage its R&D portfolio?
So our National Aviation Research Plan has long-reaching effects into the implementation of NextGen for the future. As such, it's an extremely important investment that not only advances innovative ideas, but it helps us to make the better decisions for where we need to be going forward. So in the long run, an investment in research, engineering, and development can lower the cost of more mature programs down the road. The RE&D program is a rather small part of the NextGen portfolio that falls under my overall purview, although it has been rather healthier in the last few years than it has been in the past. So we have intricate plans developed for moving forward. Dr. Hansman has made a reference to those. We need to take a look at the impact of our investments, use those plans to see what the long-term impact would be. the question about what would you cut versus what you keep, it's not that simple because of the interdependencies across these programs. So any decisions about funding need to take into account those long-term interdependencies.
Mr. Bunce, once a new additive is approved, what is the scope of work involved to certify the use of new avgas formulation into the existing general aviation fleet? Will it be as simple as certifying each type of power plant, or will certification involve approving the fuel's use in every model of airplane in the fleet today? And how likely is it that engines and fuel systems may have to be modified to accept a new fuel?
Mr. Chairman, we're hopeful that the fuel that we're developing right now is a fuel that all of these engines can use, but each one of those different models does have to be certified. So heretofore, what the FAA did was basically we had the set fuel and they certified engines to be able to operate on it. Now we're changing that whole paradigm, and the FAA hasn't done that before. They've got to certify the fuel to fit into these 200,000 plus airplanes that are sitting out there to be able to go ahead and use it. So it's a huge project because there are so many different engines that are on those aircraft, and each one of those has a substantial investment. To replace an engine right now is about, for a small piston, it's in excess of $300,000, and a lot of those airplanes just aren't worth that kind of money. So we have to be able to go and certify each one of those engines, and we have an investment of over 5,000 general aviation airports around this country that are public use airports. The commercial airlines use about 500 of them. So everything that the services we provide for getting people their airlift to medical centers, to Angel Flight, to organ transfer, and just the commerce that's created for small and mid-sized communities out there, and then of course not to mention all the agricultural business, or the fact that Alaska just survives on general aviation. There is no way that Alaska can function without piston aircraft being able to deliver supplies because there's no other way to get there, particularly in the winter. So we've got to get this right, and it's a huge, huge problem.
Thank you. I now recognize Mrs. Fudge.
Thank you, Mr. Chairman, and thank all of you for your testimony today. Ms. Cox, GAL, GAMA, and DOT Inspector General have all identified the need for next-gen performance metrics that hold FAA accountable and give Congress and the industry the ability to measure progress. What is the status of FAA's efforts to develop these metrics? And secondly, do any of the other panel members wish to comment after Ms. Cox?
Thank you. We have metrics in place to track our programmatic milestones and are doing that in great detail. The more difficult measure is how well are we doing overall with our next-gen investments. We have a group within the FAA who is focusing on developing those metrics in support of our future flight plan strategic goals. But it's not just the performance of the FAA that we have to measure. We have to measure the performance of our stakeholders, the operators in the system. So FAA has tasked the RTCA, NextGen Advisory Committee, to work with us in developing metrics not only for the FAA but for the operators to measure how NextGen is benefiting their performance.
Congresswoman Fudge, I'd just like to comment. We think metrics becomes very important, and I think Mr. Stovall pointed out that we have sayings that the FAA has used out there like best equipped, best served. So if our operators go and equip with certain technologies, we have to get a return on that investment. And the things that we would like to see from industry being able to measure is if we go and do new approaches out there and we go and equip and have these new approach designs out there, okay, how are we going to start to use them? And when we start to use them, we need to start measuring how many people want to go ahead and use these styles of approaches where we can pull the power back at altitude, descend on down on an approach, and not burn the fuel that we burn on the way we do approaches today. Now, there's a lot of elements to that. We've asked the T&I committee to help us to go and work with the NEPA process, working with the Environmental Protection Agency to streamline the way we design approaches. Right now we build approaches and then they just overlay old existing type of approaches. We don't have to design them that way anymore. We can design very curvilinear type approaches that brings a very short final and allows us to save a lot of gas coming down from altitude, and that reduces emission and it also reduces noise. So if we can put some rigor into what the FAA means by best equipped, best served, get the FAA to sponsor getting pilots and controllers together to say how best can we crack this nut to be able to go and make sure we can make maximum efficient use of the system, I think we can go a long way.
Thank you. Let me just follow up, Ms. Cox. When do you believe that you will provide the metrics to us?
The committees are working on deliverables in the September 2011 timeframe. So I think that in the very short term, we will have some metrics available to follow. And meanwhile, the FAA is also introducing new capabilities in the system in response to a previous task force recommendations. And to Mr. Bunce's point, we're looking to provide benefits to operators who are already equipped today. With that in mind, we're going out and looking at metroplex areas where we can introduce these kind of fuel-saving capabilities that he's alluded to. And our first study teams have completed their assessment of the Washington, D.C. metro area and the North Texas metro areas and have come up with some specific recommendations that will benefit operators there. And we're moving on to address 21 total metroplex areas.
Thank you very much. Mr. Scoville, you state that although ERAM passed testing at FAA's Technical Center and achieved government acceptance, testing at initial operating sites in Salt Lake City and Seattle, but it revealed significant software-related problems and that have pushed schedules well beyond original completion dates. Can you clarify the meaning of those test results, and what does this variation say about the robustness of FAA software testing?
Thank you, Ms. Fudge. If you had asked me about ERAM a year and a half or 2 years ago, I would have told you that we had great confidence in the program at that time. It appeared that the requirements for the contract were stable, that the program management was consistent and capable, and timelines for cost and for performance appeared to be on track. Things appeared to unravel, however, about the time that the product was presented to the FAA Tech Center in New Jersey for testing and government acceptance. Frankly, it's quite disturbing. We've been asked, my office has been asked by the House Appropriations Committee to do an in-depth study of the ERAM program, and this is an area that we're going to have to dive into. It appears that an incomplete version of the product was presented to the Tech Center initially. It was lacking some of the key software code, that portion being specifically that would enable key interface between the test sites in Salt Lake and Seattle and other air traffic facilities. The Tech Center never had an opportunity to test that. It appears also, and this has been noted by MITRE, that the Tech Center didn't have the capability to do all of the testing that would have been desired. And FAA correctly points out that in any event, testing at the Tech Center might well have been imperfect, since you can't plug a product like this into the NAS and have it direct live traffic. It had to go out to the test centers at Salt Lake and Seattle. Once that happened, that's where some of the key defects became apparent. Interface issues, radar processing issues, erroneous flight data tagged to aircraft, and handoff problems between controllers specifically. The problems became so acute that the system had to be taken offline. Those centers had to resort to the legacy host system in order to direct high-altitude, long-range traffic. And now we find ourselves in a position where FAA itself says that ERAM delivery will be delayed by about 4 years and cost an extra $330 million. MITRE, on the other hand, says a more accurate number might be to 2015 or even 2016 and perhaps $500 million. So a lot is at stake in delivering this. ERAM is a key enabling platform for a number of critical programs that are truly next-gen related, as Ms. Cox has noted. FAA will get ERAM right. It'll take a lot more time and a lot more money, but in the meantime, it does raise questions for us about the adequacy of the Tech Center's program's inability to conduct key testing like this, and also, frankly, with the contract negotiation and management point. If problems with testing at the tech center were known or should have been known, why were those not taken into account in the contract process so that the government alone would not have borne the total risk? Could have been spread between government and contractor, perhaps. We'll look at that and report to the department and to the Congress.
Thank you so much. I yield back.
I now recognize Mr. Sensenbrenner for questions.
Thank you very much. My question is basically on what is being done to plug the holes in the air traffic control system. Let me say, at the end of June last year, I was on a United Airlines commercial flight that was going into Washington National Airport. And because there was a line of thunderstorms between Dulles and National Airports, my plane was taken off the regular approach pattern into National. Shortly after that, the collision avoidance system went off twice on the plane that I was on. The plane made some very rapid and very sharp maneuvers in order to avoid a collision. And I asked the FAA to come and show me the tapes, and I came within 100 feet of being wiped out together with about 110 other passengers. And the Washington Post has run a whole series of stories as a result of this relative to near collisions. Some people call them near misses. I think it's better to call them near collisions in the skies above DCA. And with the number of people that go in and out of DCA, members of Congress and government officials, I think it's important to plug the holes lest there be, a huge tragedy. What apparently came out of this investigation was that there was a manual handoff, or what was called a splat between the National Airport controllers and the Dulles Airport controllers. And the National Airport controller handed control of the plane off, he thought, to the Dulles Airport controller, except the Dulles Airport controller never picked it up. This was something that was done manually. Apparently there was no training on the part of the Dulles Airport controller, who was relatively new in the FAA, and since he didn't know he was in charge of dealing with both the general aviation plane that took off from Dulles as well as my United Airlines personal or commercial plane, we came very close, like 400 feet, to having a tragedy. What is being done to prevent this from happening again?
So a large part of the focus of the NextGen program is on better managing how we control traffic in very congested airspace, such as the situation you described. Providing better tools to the controllers so that they can be alerted to potential conflicts, such as the one that you experienced, and help them to deal with it in a more automated fashion. As you point out, very much of the system today is a manual system. A lot of tracking is done by the human, and we're looking at ways to automate some of that. From Dr. Hansman's presentation, you also saw the impact that weather can have to further exacerbate this situation. NextGen also invests in better tools for predicting the weather so that further out in the system we could have placed that traffic more efficiently and effectively for getting it into their airport of destination. So these are the kinds of investments that we are looking at.
Okay, but I just heard that NextGen is going to require a lot of money, which we don't have at the present time, and take quite a bit of time, like maybe 5 years plus, to become effective. And I just don't want to see a tragedy occur, whether it's in the congested airspace over the D.C. area or someplace else. Is there anything that is being done on a more immediate basis to prevent one controller handing control of a plane off to another controller and the other controller doesn't pick it up?
So you're correct. Some of these investments in automation systems do require long-term investments and longer-term deliveries. Some of the things that we're looking at are better control on the surface and integrated arrival departures that manage those departures better, and some of that capability is being delivered today. So if the conflicting traffic is one, a departing aircraft, for example, we are investing in capabilities that will address that. And I will say that...
And when will it be addressed?
For the
Do we need to have a mid-air collision before it becomes an urgency on the part of the FAA?
I think that the safety of the system is always an urgency with the FAA and has our attention, and we believe that we are one of the safest systems in the world.
Well, you know, so do I. But the situation that the commercial airliner that I was on was serious enough to warrant the NTSB's investigating this. And I don't. It always takes a while for them to figure out, you know, what went wrong. But I'd like to know that when the NTSB, you know, reaches its conclusion, that there would be immediate implementation of whatever recommendations they make. And I haven't heard anything in this hearing to put my mind at ease.
You know, I can't speak to the outcome of the investigation. I'm certain that it will be taken very seriously. Another investment that NextGen is making today is in our ability to take data such as you described and others that are less serious than the incident that you described, track that data and develop capabilities to assess it so that we can avoid those incidents in the future. Not wait until the incident happens and then do the investigation. The ASIAS, or the Aviation Safety Information Assessment Sharing program that NextGen funds, will help us make this a safer system.
Thank you.
Dr. Hansman, did you have anything you'd like to add?
Well, I was just going to point out that while this was a mistake in the system, I think it also illustrates that we actually do have redundancies in the system that provide protection. So there was a secondary collision alerting system that the crew had to prevent a mishap. Some of the things that are happening in...
If you yield, the secondary system that was on board the Airbus 319 that United was flying went off twice.
Sure. And so it worked.
Yeah, it worked, and I'm here today because it worked.
Yeah, and I think one of the things that's happening in NextGen is we're adding additional levels of redundancy in the system. So some of the things that are happening, for example, with ADS-B, is the GA airplane in the future, which wasn't equipped, I presume, will probably be equipped. That will also have collision alerting systems. So there are things that are happening.
All right, thank you. I now recognize Ms. Sewell for questions.
Thank you, Mr. Chairman. I'd also like to thank the panelists for your testimony. My question actually has to do with the Joint Planning and Development Office. Ms. Cox, the OIG says that there is confusion within FAA and the industry about the JPDO's role in advancing NextGen. While the OIG acknowledges that FAA recognizes the need to better define JPDO's mission, no definitive action has been taken to determine what role, if any, JPDOs will play in the critical NextGen implementation. My question is threefold. Does FAA agree with OIG's assessment? Secondly, what specifically do you plan to do to address this concern?
So I believe that the role of the JPDO is somewhat better understood. They have a role with keeping an eye to longer-term research that will provide the vision that the FAA can aim its nearer-term activities toward achieving. So those long-term goals are theirs. The other mission of the JPDO is the one that Mr. Scoville alluded to, which is the interagency contributions to the next generation air transportation problem. And I think we do concede that interagency cooperation is a very challenging undertaking. We have made some advances with the help of the Joint Planning and Development Office in leveraging some research going on in other agencies. With NASA in particular, upon whom we depend so much for a lot of the more basic and fundamental research that contributes to our more applied efforts, we have been working very closely under the auspices of the JPDO with research transition teams. We're focusing in 4 key areas that will help us improve NextGen. The JPDO this past fall called together a workshop of the Air Force Research Laboratory, NASA, and the FAA to look at long-term planning for unmanned aerial systems operating in the National Airspace System. So we're hoping to leverage those capabilities. FAA has brought, the Department of Defense named the Air Force as their chief agency with responsibility for NextGen integration. The Air Force has assigned a liaison who is resident with us at FAA headquarters to assist us in this effort. And we are working very closely with the National Weather Service in planning some of our joint weather plans for the future.
Inspector General Scoville, do you agree with her assessment?
Thank you, Ms. Sewell. I would like to note, and it's more than just an historical footnote, but I think much of the confusion and disappointment with our industry stakeholders in the JPDO's role stems from the decision in 2008 to place the JPDO within the Air Traffic Organization, in effect to bury it. The Air Traffic Organization, of course, is rightly concerned with safe operations of the NAS 24/7. The JPDO is designed to look long-term in executing NextGen. By placing it under the ATO, the rationale was to make sure that long-term plans will align with the operators who have to carry them out, but in effect, the JPDO languished. It drifted for a couple of years. It's now been removed from the ATO. It's now placed directly under the Deputy Administrator, and Mr. Huerta has taken a very keen interest in making sure that the JPDO steps forward to take its rightful place, not only for long-range next-gen planning, but also, we hope, and industry hopes, along some of the lines that I outlined in my statement, for simulation and modeling, perhaps, technology transfer, most certainly in the multi-agency role, prototype development, and policy formulation as well.
Dr. Hansman, you stated that the JPDO has not been effective as a long-range planning office. And after playing an important and significant role in identifying the needs for NAS modernization, the JPDO has lost its focus, is what you said. What needs to be done to restore the JPDO's effectiveness, in your opinion?
So I think there are a couple of challenges. One is the challenge of basically having too many bosses. So you have an organization that when it began was fairly bold in its vision, but then became timid because it was afraid of offending, making some of the hard decisions. So I think that's one thing. I think they also need to be looking forward not so much at micro-designing what the system will be in 2050, but really tracking what the future demands and challenges on the system would be. So, for example, it's disappointing that the JPDO is not more focused on environmental concerns in efficiency issues, which have emerged after the initial definition of the plan, but they were very slow to respond. So I would much rather see them really taking longer-term view of what the requirements are as opposed to the detailed design of exactly how a procedure is going to work in 2050.
Ms. Cox, do you agree with his critique?
I think that the suggestions are quite good in terms of looking to the longer term and focusing there. So in general, yes, I do.
I yield the rest of my time.
Thank you. I now recognize Mr. Rohrabacher for questions.
Thank you very much. And Chairman Palazzo, I want to congratulate you for, I take it this is the first hearing of your subcommittee, and you have chosen for the first hearing of your subcommittee a non-space related issue. And sometimes the criticism, and I think justified criticism, of this subcommittee is that it spends all of its time on space when there are general aviation issues and aviation issues that are vitally important to the security and the prosperity of our country. So I appreciate that. We all know that Gabby Giffords isn't with us today, and we're sad about that. And we certainly wish her well and hope she gets back very soon. I'd like to get back to priorities and things, and gentleman just mentioned too many bosses. And one thing that seems to be coming out of this hearing at me is that we got this bureaucratic system that's all around us, and looking at components of this next generation. And it seems to me that maybe that we have in every one of those departments or components that we're trying to place this part of the effort here or over here, what is the ratio? Maybe I should ask that of our Inspector General here. What is the ratio there of bosses versus engineers and scientists and people doing the software and people who are doing the grunt work that needs to be done? What is that? Do we have a system that has too many bosses?
Thank you, Mr. Rohrabacher. I can't peg a number to answer your question. We haven't done work in that specific area. I can tell you, however, though, that when we have, as we did in 2007, recommend to FAA that it take that it undertake an analysis of its acquisition workforce, specifically those skills that would be needed for NextGen. FAA concurred in that recommendation, contracted with the National Academy of Public Administration to do that. NAPA presented its report in September 2008 and identified, in fact, 26 key competencies that were needed, the grunts, if you will, not just the top leadership level. FAA has moved, we think, quite slowly in filling those, filling the trenches with those grunts in key areas like.
Could that be because the people making the decision to hire the people who are actually doing the real work know that the budget's coming out of the money that they would go to pay to them? I mean, this sounds like to me we got an awful lot of people managing some engineers who are actually doing all the work.
I don't know what the rationale, sir, is. I can only report on the results, which are that key skills like program management, software development, systems engineering and integration, specifically, for instance, having to do with an emphasis on human factors, which is what NAPA identified. Some of those areas are lacking. My office is currently undergoing or undertaking another review of FAA's acquisition workforce, and we're going to try to peg those specific deficiencies with greater specificity.
Well, when I asked the original question, thank you, Mr. Chairman, for granting me that 1 minute with the unanimous consent, and I said, what are your highest priorities? Would I take it then that your highest priority is not hiring more managers for this system, but instead hiring more people who are actually getting the software done and the engineering done on the technology? Would I suggest that that might be your top priority and your lowest priority right there?
It's certainly key. And in our statement, we identify that as one of the 5 action items that we have recommended to FAA in this area.
Well, remember, we're going here on a $40 billion program. We're being told that it went from, and the date for the actual put it in place went from 2025 to 2035 now. How is that affecting the bottom line? Is that, maybe I should ask Ms. Cox about that?
The original 2025 date was for the visionary system that was described by the Joint Planning and Development Office back in 2004 when the authorization set that office up. The FAA has done some careful assessments, looked at research requirements, and come up with what we believe is an achievable plan that will, in essence, transform the way the system operates in a more midterm time frame. And our plans focus toward those deliverables, which, granted, are not as visionary, perhaps, as the original 2025. The JPDO, meanwhile, continues to focus on the long-term vision and look at what we can realistically connect that research to deliver a capability in the future, because we can't just stop in 2025 or 2018 or we must continue to look forward, and that is our goal, and that's why the investment in the research and engineering is so very important
and
as well.
when is that date when this new system is going to be evident, although it's not complete?
I think there's evidence today that we are introducing new capabilities.
Okay.
For the general aviation community in particular, access to airports that they never had access to before is available through space-based nav aids that provide access to operators who are equipped, and they are equipping at remarkable rates.
Okay, one last question, Mr. Chairman. The FAA budget, is it $346 million a year research budget? Is that for overall FAA, or is that a NextGen?
The President's 12 budget request is in the $380 million range for our National Aviation Research Plan. The total NextGen request is in the $1.2 billion range.
Okay, got it. Well, thank you very much, Mr. Chairman.
All right, with the committee's indulgence, I will conclude the hearing with one last question. Mr. Scoville, Mr. Hansman, whoever wants to respond to this is fine. But I think it's pretty much your statement, so might want to back up. Might not be everybody's. Your statement suggests that a high-level participating agencies are not realigning their R&D budgets and programs to aggressively support NextGen. With the exception of FAA and DOT, is NextGen's implementation imperiled because of indifferences or diminishing commitment of some or all the partnering agencies?
Thank you, Mr. Chairman. I think imperiled is probably too strong a word. Is there potential for delay? Most certainly. Is there potential for missed opportunities? Absolutely. I would characterize FAA's success in the multi-agency effort as frankly being patchy at this point. They've had some successes working with NOAA and Defense along weather lines, but at the same time, Commerce has made clear that they're going to work on the 4D weather cube to suit Commerce's needs until FAA is able to better articulate and define what FAA's weather needs are for NextGen. It's been the same with DoD when it comes to unmanned aircraft systems and surveillance needs. Human factors is also another area that needs greater attention. So I think FAA is going to get all this right, but it's frustrating for us and frankly for some of the other agency partners, DoD in particular, when it comes to unmanned aircraft systems, to see FAA's seeming inability in a prompt manner in the views of the other agencies to define what the needs are so that the agencies can work in a way that they think will suit not only their own needs but FAA's.
Mr. Chairman, would you indulge me one more question?
Let Dr. Hansman answer, and then absolutely I'll recognize you for one additional question.
So I was just going to mention that there has actually been good collaboration with NASA on NextGen, so I think that's been a good interface. I agree that there is a tension between the DoD and the FAA, particularly in the area of UAV operations. There's also, I think, a concern on the part of of the DoD that a lot of the NextGen plans presume airborne equipage, and it's very difficult for the DoD to be able to afford the equipage for the number of airplanes that they have.
Mr. Chairman, I'd just add an industry perspective for you on this. One of the things that we've been very disappointed about is the involvement of the Department of Homeland Security in the process as well. When you look at what we're able to do with the NextGen system, and when we deploy ADS-B and we have this capability out there, the original vision was we could get rid of some radars. And radars are expensive down on the ground. We're basically, these ADS-B boxes that we're putting all over the country are about the size of a refrigerator, much smaller, much easier to maintain, and we're moving a lot of the infrastructure up to the air. As you go, you would think that as we deploy this system that we'd be able to get rid of a lot of the old technology that we've been relying on. But there's a concern out there about people that don't want to cooperate, what's called non-cooperative targets, and want to turn off their systems. How are we going to monitor those? So who's going to be responsible for those radars that are no longer needed by the FAA that have to be either picked up by Homeland Security or picked up by DOD? And that's where I think industry's frustration is as we look at the interagency process and try to see, okay, who's all sitting at the table, and when they go and the JPDO talks about this long-range vision, when the FAA comes and says we want to do that, deploy this next-gen system, where can we reap some savings, and then who do those responsibilities now transfer to? And that's why we have to get everybody at the table, and the only people that are going to be able to drive that is going to be at the administration level, where they can say to the secretaries, you got to get people to sit down at the table and hash this all out and make the JPDO process work.
Mr. Chairman, can I make a small clarification in terms of the FAA's planning for the radar systems? With the advent of ADS-B, Automatic Dependent Surveillance Broadcast, as our primary surveillance system, the FAA has judged that it can remove about 50% of our secondary radars that track traffic in the immediate terminal areas for us. And we can do that by resiting some of the existing radars and get the same coverage that we have today. The longer range radars that track the uncooperative targets are today under the management of the DoD and the DHS, but maintained by FAA, and there is no plan to remove those radars.
Okay, thank you all. The chair recognizes Mr. Rohrbacher for an additional question.
Thank you very much, Mr. Chairman. I would just like to ask Mr. Scoville to, I'm sure he can't answer this question now, but maybe you could get back to me with an assessment from your organization as to what the actual cost is here between managers and administrators for the NextGen generation project versus the actual online personnel who are the scientists and the engineers. I think it would be good for us to know what are the administrative costs. And, you know, at some point you can hire enough administrators that they have to find reasons to argue with one another, and they actually get in the way of people who are actually developing software, et cetera. And I'd just like to get a better understanding of this particular program and where the costs are in terms of personnel. And that would be, I think, helpful for us to do our job here in making sure that we make sure the money's being spent efficiently. Thank you very much. Could you get back to me with some assessment of that?
I'd be happy to, sir. You're right that we don't currently have that information, but we'd be glad to take a crack at it for you.
Thank you.
I thank the witnesses for their valuable testimony and the members for their questions. The members of the subcommittee may have additional questions for the witnesses, and we will ask you to respond to those in writing. The record will remain open for 2 weeks for additional comments and statements from members. The witnesses are excused, and this hearing is adjourned.